Hi everyone, thanks for taking the time to watch this presentation. Today, I'm going to be talking to you about how you can build containerized microservices faster and ship with confidence using Visual Studio, Visual Studio Code, and GitHub Actions. Since microservices and Kubernetes are such a trending topic right now with application architecture, I'll start off by providing a brief overview of what they are and the benefits of combining the two. Then we'll cover the challenges developers are faced with when working on a microservice application running in Kubernetes. We'll discuss the different development approaches that address these problems, and I'll share learnings for each. We'll focus on one approach that Microsoft is investing in based on feedback we've received from developers. And we'll wrap things up by showing a post-commit workflow where I'll demo how you can raise confidence in your pull request with a GitHub Actions workflow. But before we get started, I want to take a moment to introduce myself. My name is Nick Greenfield, and I'm originally from the East Coast. I moved to the Pacific Northwest roughly 5 years ago. I have a background in web application development, and for the past year, I've been working as a program manager on the Azure DevSpaces team here at Microsoft. So we're going to start off by talking about microservices and Kubernetes. Microservices consist of componentizing an application based on business capabilities. These components commonly communicate to each other over the network using protocols such as HTTP, gRPC, and event-driven messaging, to name a few. Containers are commonly used as a way of packaging microservices. They include everything that is needed to execute your code, such as dependencies, libraries, and the code itself. Containers run your code consistently and reliably from one environment to another. Some benefits for adopting or transitioning to a microservice application architecture include independent development, which allows for smaller focused development teams, more frequent deployments, which enables your development team to be more agile in its delivery process, and finally, avoiding single points of failure. By decoupling your application, failures are now isolated to that microservice with minimal effect on other parts of the application. Over the years, Kubernetes has become the de facto system for running containerized microservices. Kubernetes functions as an orchestration system for managing deployments, maintaining application health, and scaling. Some of the major benefits for running your microservice application in Kubernetes include service discovery, which is the process used by microservices to communicate with each other, autoscaling and load balancing, which increases instances of your microservice as needed and evenly distributes the load, logical segregation through namespaces, which can provide separation between teams and environments, and role-based access control. This is used to restrict the developer's network privileges based on an assigned role. Although there are many benefits of adopting or transitioning to a microservice application running in Kubernetes, there are also certain challenges development teams are faced with. You're looking at an example of a web application, in this case, a bicycle renting service, that's made up of multiple microservices running in AKS. A user initiates a request to the front end, which will then be routed to the gateway, and from there to an appropriate API. As you can see in this example, there are many moving pieces to microservice applications, and it's not unusual for a developer to only be involved with one of those pieces. For example, only working on the bikes microservice. So when it comes time to developing their microservice code, they might not know how to run and connect to the other pieces of the application that their microservice depends on. Or maybe they do know how to run and connect to the external dependencies, but doing so adds additional complexities of having to track and account for components outside the developer's responsibility. And in some cases, what we've learned from talking with microservice developers, it's not possible that a developer can run an entire microservice application on their development machine. There just isn't enough memory. So microservice developers are faced with the challenge of writing, testing, and debugging their microservice code when it has external dependencies that are outside of their domain. How do they satisfy these external dependencies during development time so that they can be confident that their code changes will behave as expected in the context of the entire application? So there are multiple development approaches aimed at addressing this challenge. One approach is to write code locally and satisfy microservice requirements locally. We'll refer to this as the local approach. There are multiple ways to go about this, such as running all or some dependencies on the developer's workstation and manually connecting via connection strings, or satisfying external dependencies by using stubs, mocks, or emulators, or even using a system such as Docker Compose to run dependencies in containers. But whatever method is used, ultimately, all microservice requirements are satisfied on the developer's workstation. The strength of this approach is that it works well when it comes to the build, test, and debug cycle. You get the speed of developing your service locally, as well as the flexibility in the development tools used. The downsides to this approach are that the development environment can be drastically different from the deployed environment where your application will ultimately run, and it does not scale well as your application matures and more components are added. And overall, ease of use is lacking. No matter what method is used within this approach, maintainability can be difficult over time. Moving on to the next approach, where code is written locally and microservice requirements are satisfied by deploying to Kubernetes. You can think of this as the remote approach. There are multiple tools that provide this capability, such as Scaffold and Azure DevSpaces. Compared to the local approach, the remote approach is lacking speed and flexibility within the build, test, and debug cycle. This approach often requires specialized tooling and introduces the extra step of deploying code, which can significantly slow down the development loop. However, it exceeds the local approach in both fidelity to a deployed environment and how it handles application scaling. Code changes are tested in a similar environment to where your application will eventually run in Kubernetes. And over time, we have come to understand that perhaps the most important pitfall of this approach is that the development style introduces operational concepts that most developers are not accustomed to. Developers now have the extra burden of understanding Docker and Kubernetes configurations as well as Kubernetes deployment concepts. Having to learn and understand these additional concepts distracts the developer from focusing on the business logic of their code. As you can see, both the local and remote approaches have solid strengths, but also critical flaws. This last approach, which can be thought of as a hybrid, shares the strengths of both the local and remote approaches. The developer writes code locally and satisfies their microservice requirements by connecting to dependencies in Kubernetes. This provides the developer with speed and flexibility of writing, testing, and debugging their microservice code locally while using tools they are already familiar with. At the same time, this approach delivers the high fidelity of a deployed environment. A developer can take advantage of external dependencies and environmental configurations by connecting their development workstation to a deployed environment, in this case, a Kubernetes cluster. This also enables testing code changes end-to-end by leveraging most of the application already running in the deployed environment. As your application matures and more components are added, this approach does not change. Developers only focus on running their microservices they're responsible for. Overall, this hybrid approach is easy to use. As long as the developer has access to the Kubernetes cluster where their dependencies are running, they're able to use this approach. Microsoft has been investing in this approach, and I'd like to take this time to show you an example of how you can satisfy microservice requirements by connecting your developer workstation to a Kubernetes cluster using Visual Studio Code. So let's revisit the bike renting application that we were previously looking at. This application does exist and is running an Azure Kubernetes service. Let's say I'm a new developer on the bike's microservice team. I've been tasked with fixing a bug where all bike images are displaying a static placeholder image instead of the picture of the actual bike. My operations team has set me up with my own private instance of the application running in my own namespace, so I'm free to troubleshoot without impacting my teammates. Let's start off by trying to reproduce the bug. Alright, so here we are on the home page of the bike renting application that's running in AKS. I'll start off by signing in. As you can see, there are multiple bikes that are available to rent. I'll select one from the list and can immediately see there's a placeholder image where the picture of the actual bike should be. So this is the issue that we're going to fix. I've already cloned the bikes repo to my development machine and have it open in Visual Studio Code. I've looked through the code and have an idea of where the issue is coming from. It probably has something to do with this comment that says, hardcode image URL, fix me. So I'll comment out the hard-coded image URL and place a breakpoint so I can inspect the bike object. Now let's run the bike service to trigger the breakpoint. This is a Node application, so I'll use my existing npm launch profile. As you can see, my service encountered an error. That's because my code is trying to make connections to external dependencies that are not configured. Here's where I can take advantage of the new local process with Kubernetes feature in Visual Studio Code. It doesn't matter that I'm not familiar with these external dependencies my microservice relies on. By using this feature, I can fulfill them by connecting my development machine to my cluster where the dependencies are already running. So let's give this a try. So I'll stop my current debug session, and I'll switch my debug profile to local process with Kubernetes and hit play. I'm presented with a one-time configuration prompt that defines the connection between my development machine and the cluster. I need to tell Visual Studio Code which service in the cluster I'd like to redirect to my version running locally and on which port. It's at this point my development machine is making the connection to the cluster. On average, this only takes a couple seconds. Okay, the connection has been made and my bike service is now running locally. As you can see, configurations from the cluster, such as environment variables, are now available to my service running on my machine. I'm going to try to trigger the breakpoint that I set earlier by hitting my cluster's public endpoint. The request will start in the cluster, and when the bike service is called, it will redirect to my development machine to use my version of the bike service. Let's give this a try by following the same steps I took earlier to reproduce the issue. So I'll sign in, select a bike to rent, and success. My breakpoint was triggered in the bike service running locally. The request to my cluster was redirected to my development machine when the bike service was called. So now if we inspect the bike, you can see the image URL is no longer referring to the static placeholder. So let's hit play and continue. And now a picture of the actual bike appears. So one thing I'd like to point out is that the only code I had to run on my development machine was the bike service. Also notice there are no Docker or Kubernetes configurations in my repo. I'm running the code natively. So to recap, I was able to fulfill external dependencies by connecting my development machine to the cluster where they were already running. By doing so, I'm able to develop, test, and debug my microservice code on my development machine end-to-end in the context of the entire application. The local process with Kubernetes feature is not only available in Visual Studio Code, but will soon be available in Visual Studio as well. Let me take a couple moments to show you what that experience looks like. So I have Visual Studio 2019 open, and I've changed the microservice that I plan on debugging. For this example, I'm running the bikes reservation engine, which is a .NET Core service. The dialog that is currently open is pre-configured to connect my development machine to the cluster and redirect the reservation engine service to my version running locally. So now I'll click OK and place a breakpoint in the code. I'll put it in the reserve bike method and hit F5. It's at this point that VS is creating the connection between my dev machine and the cluster. Notice I get the added benefit of VS launching my application running in AKS so I can start debugging immediately. So I'll log in, I'll select a bike to rent, in this case the Men's Comfort, rent the bike, and success, my breakpoint was hit. I want to take a couple moments to share what's happening behind the scenes with the local process with Kubernetes feature in both Visual Studio and Visual Studio Code. The first thing that happens when we initiate the debug session is we create a connection between the cluster and the developer's workstation. This allows us to put a redirector in place of a running service. So in the example I showed in Visual Studio Code, I chose to replace the bike service. So when the request was made through the front-end entry point of the application running in AKS and eventually called the bike service in the cluster, that request was redirected to the developer's machine where an instance of bikes was running locally. It's at that point a developer can test their code changes as necessary and send the request back to the cluster to be completed. So we're going to change gears and transition into a post-commit workflow. Development teams often collaborate in feature branches and pull requests. When finishing feature branches, developers will submit pull requests for review before merging into the application's main branch. This process is typically limited to static code diffs where newly committed code is reviewed to meet the team's standards for consistency. And unfortunately, this process is commonly scoped to team members who directly work on that specific part of the application. Additionally, when working with microservice applications, there is minimal visibility of the end-to-end impact on the application behavior when modifying an individual service. With the GitHub Actions and Azure DevSpace's pull request flow, you can test your code changes before code has been merged into the application's main branch. You can create review apps for integration testing where team members can confidently approve pull requests by ensuring the new changes will not have a negative impact on other services in the application. And as an added bonus, team members such as designers and program managers can become part of the review process during early stages of development. Let's take a quick look at how you can increase confidence in your pull requests. We're going to continue with fixing the bikes image example. We'll pick up from where we left off when we commented out the static image URL. The changes work as expected and I'm ready to commit my code. But before doing so, notice in the bottom left corner of my screen on my source control status icon that I'm working off of a feature branch called bike static image fix. So I'll go ahead and stage my changes. I'll provide a commit message and I'll push to GitHub. Now I'll navigate to GitHub to create a pull request for my feature branch. So as soon as I do this, a GitHub Actions workflow triggers. The workflow will deploy my pull request changes to a sandbox environment that I can use to test my changes before merging into the application's main branch. This process takes a couple minutes, but we can fast forward to a workflow that is already completed. So once the workflow completes, a specialized URL based off my feature branch is written to my pull request that I can test my code changes end to end. So if I click this URL and I sign in, I can see that my changes have been applied. So I'd like to point out that these changes are isolated to my sandbox environment and do not impact the application running in the dev integration environment. I'll show you an example side by side. The URL on the left is my pull request sandbox environment, and the one on the right is my dev integration environment. To summarize what we've covered today, microservices and Kubernetes are powerful when combined, but can introduce certain challenges to developers with external microservice dependencies. Local process with Kubernetes helps address those challenges by reducing the complexity of setting up and developing multi-component applications. Local process with Kubernetes will be available as a preview experience in early June 2020 in both Visual Studio and Visual Studio Code. You can use GitHub Actions and the Azure DevSpace's pull request flow to raise confidence in your code changes through interactive review apps. And lastly, are some additional resources that you can use to probe deeper into the scenarios we've discussed. Please feel free to reach out through our GitHub issues page or by email. Thank you for your time.